Hello and thanks for tuning in. I've got a circuit here that has two batteries in it, which makes it a little bit trickier to deal with than, a normal series or parallel circuit with one battery. And we can handle that pretty easily using Kirchhoff's law. So this is just going to be a step-by-step solution on how you can do that. If you're looking for more background on Kirchhoff's law, I'd recommend watching a different video first. So let's jump right in. The first thing I like to do is establish which way the current is going. This is for conventional current. So it's just going to go from the higher voltage to the lower voltage. Pretty easy in this one. You've got 12 volts and 4 volts for your two sources. So the current will go this way. Okay, and I'm going to call that current 1. Of course, we use I to denote current. Then at this point here, we'll mark it in blue. We call this a node. The current will branch off into two more currents. I'll call this one I3 and this one I4. I'm going to write it just down here so there's a little more space. Alright, and you can think of current as a little bit like water. If water's flowing into a valve, however much water is going in has to go out. So one of the things we can take advantage of here via Kirchhoff is that I1 has to equal I2 plus I3. Okay, and that's true for any node. It'll also be true down here. You would get the same thing at this other node. Well, in this case, maybe you look at it as I2 plus I3 equals I1, but you get the idea. And I'm going to rearrange this. I'm going to subtract I2 and I3 to the other side. And so it'll look like this, minus I2 minus I3 equals 0. And that's just because, well, we have three variables here, right? So we're going to end up with three different equations. And you'll have to solve this system of equations. So it'll be a little bit easier if I write everything out left to right with I1, I2, I3. So I'll do that when I do these other loops as well. Now, for the next part, I'm going to do some Kirchhoff loops. So if you can remember, the voltage has to sum to 0 when you go around one of these loops. And to make it just a little bit easier on us, I'm going to pick the loops, both of them as clockwise, okay? And that's just so they flow in the same direction as the current. It's a little bit more natural to do it that way. So I'm going to do that one, and the black one, it doesn't really look like an arrow, but you can imagine it's an arrow going counterclockwise. And the brown one, it's kind of the same thing, going around all the way around the outside, okay? So those are my two loops. And let's do the black one first. So see if you can just follow this. Now, you start out with 12 volts. Okay, so I'll write 12. And then, yeah, when we go through all these voltage drops, you have to end up back at 0. So the first voltage drop happens through the 4 ohm resistor. And by the way, the units of all these are ohms. I just left it out to save some space. So you've got current 1 going through a 4 ohm resistor. Now from Ohm's law, voltage equals current times resistance. So to get the voltage drop, it's just the 4 ohms times current 1. So I'll write 4I1, and then going down the red part, okay, just continuing the loop, minus 6 times I2. And then for the battery, this looks a bit tricky, but it's really quite simple. Just minus 4. Okay, because you get a 4 volt drop across that. That's got to equal 0. Alright, and 12 minus 4 is 8. So I can simplify this a little bit. And since I want this in I1, I2, I3 form, just so we have nice rows and it's easy to solve the system of equations, I'm going to add 4i1 and 6i2 to the other side and just rewrite it so it'll end up looking like this. 4i1 plus 6i2 equals 8. So that's just an algebraic rearrangement to make it easier to solve later on. For the next one, the brown loop, similar, I start at 12 volts and subtract 4 ohms again times I1 minus, and now I3 is going around the outside and it goes through an 8 ohm resistor, so minus 8 I3, and that will equal 0. Okay, because for the rest of that loop there's nothing else in the way causing a voltage drop. We assume the wires are perfect, meaning there's no resistance in them. And again, I'm just going to rearrange this by adding I1 and I3 to the other side. So I get 4I1 plus 8I3 equals 12. Okay, and now this is all we have to do from the electronics perspective. Now you want to put your math hat on and just solve the system of equations. And if you want to, you could stop watching the video and just solve it yourself, but I'll show you how I would do it. And I'm essentially just going to make these into a matrix and solve them using my really advanced TI-83 graphing calculator. So let me just lay out the framework of this matrix. It's not all that complicated. So you have the 3 currents in the columns, and then you'll also enter in sort of whatever your voltage is. I'll talk about that a little bit more in a second here. So going back, yeah, I'll just show you what I would do. So for the first line, you have a 4 times I1 plus 6 times I2, and there's 0 times I3, because there's no I3 term. That equals 8. So here's how I'm just going to enter it. 4 in the I1 column, and then 6 in the I2, 0 here, and 8 here. Alright, and we just do that for the other two. And by the way, it doesn't really matter which order you enter these in. It'll still be easy to get the solution using a graphing calculator or some solver. So here I1 has a coefficient of 4, I3 has a coefficient of 8, I2 0, and 12 for V. So I'll do 4, 0, 8, 12. Okay. And so it looks good so far. For the last one, now maybe you say these don't have any coefficients. Wrong. 1, -1, and -1, and then for the last one, 0. So 1, -1, -1, and 0. Okay, and when you have this matrix, you can go ahead and solve it. I'll show you how I did it in the TI-83. Okay, so there are a few steps here on this page, and I'll reference a video in the comments as well, or not in the comments, in the description, where you can maybe get a more complete version of this. But essentially you go to second matrix, then edit, then A. I picked A, you can pick whichever one you want to, but you put in all the values. It'll be a 3x4 matrix. You'll have to put them in one by one. And then after that, second matrix, then go over to math, then you have to scroll way down to RREF, this is reduced row echelon form, and click enter, and that should take you back to the home screen, and it'll look kind of like this. Ooh, a little bit of a teaser to what the answers are. You just won't have the A in there yet. And then step 3, go again to second matrix, then matrix A, that's what you just created. Put it in there, close the parenthesis, hit enter, and your solutions come up. Now, what does this mean? Because I know you might get this and be a little bit concerned. All it means more or less is, well, if you look here, I1 was the first column. So here there's a 1 in that column on the very first row. So that means 1 times I1 equals 0 I2 plus, 1 times I1 plus 0 times I2 plus 0 times I3 equals 1.31. So, okay, to simplify that, I1 just equals 1.31 amps. Okay, and then I2 is in the second column, so you see that there. I2 equals 0.46, and I3 will then be equal to 0.84. Of course, all these have units of amps. And if you don't have a TI-83 calculator, I guess you have a couple options. You could just Google search a system of equation solver or calculator, Google or something like that. Also, I think you can download the TI-83 app for free on your smartphone. So the last thing I want to mention here is that you just want to check it to make sure that you're not too far off. And if you remember from our junction, this is a really intuitive way to check. We had I1 going into this node, and then it breaks up into I2 and I3. So I1 should be equal to I2 plus I3. So let's just write that out. I1 equals I2 plus I3. Is this true? Well, 0.46 plus 0.84, I2 plus I3, does in fact equal 1.31 amps. So we can't be too far off. So that's a nice check for us. If that wasn't true, then it probably means you entered something wrong in your initial matrix here. Okay, so you just want to be careful when you're entering all those values. And I'm hoping I didn't make a mistake there. But it looks pretty good. So if you found that helpful, you can go ahead and like the video. And thank you for watching. If you have any questions like this, or similar to something else, you're welcome to write me a message and I'll see what I can do to help. Okay, thanks again for watching.